Okay, welcome back once again. We're going to factor quadratic form polynomials, and quadratic form polynomials are polynomials that resemble basic polynomials, except that maybe something is added in to make it look slightly different. But in each case, what happens is that whenever we have a variable or variables in our expression, for the first term, the exponent is 2 times whatever the variable is in the second exponent. Right, so here's an example of that. We've got x squared y squared minus 9xy plus 20. Well, this is definitely of that form because we've got a square, only in this case our variable is x times y, and x times y squared, right? We could think of this as being xy squared minus 9 times that quantity xy, that's to the first, plus 20. And so any factorization that we would use in this format, that's exactly what we would do right here. And so we would need to find two factors, two binomial factors, whose first term is xy, and whose last term is going to be whatever factors of 20 whose sum is negative 9. Well, in this case, that has to be negative 5 and negative 4. So our factorization would be xy minus 5 times xy minus 4. And of course, you should check just to make sure. Let's be on the safe side. If we check this out, well, of course, first term, xy times xy is xy squared. Outer terms, negative 4xy. Inner terms, negative 5xy. And our last term is negative 4 times negative 5 plus 20. And sure enough, that seems to work out because we get x squared times y squared when we distribute the power, minus 9 times x times y as our middle term, plus 20 as our last term. So that seems to work out. All right, let's try this one. We've got y to the fourth times minus 8y squared minus 48. Well, in this case, again, this is like one of those. This is almost as if we're saying, take y squared minus 8 times y squared minus 48. And that is certainly of the form of our trinomials right there. And that should be 48, not 98. I don't know why my pen keeps on doing that, but it insists. So, all right, now what? Well, this is the square of something, minus 8 times the square of something, times something, pardon me, to the first, right? Y squared to the first. That's like this. So we need to find two binomials. And we're going to find two binomials that in the factored form start with y squared this time, so that y squared times y squared would give us y to the fourth the first time, and then terms that have factors of negative 48 whose sum is negative 12. Well, it turns out that a good pair is negative 12 and positive 4. Negative 12 times 4 would be negative 48. Negative 12 plus 4 would be negative 8. So we're going to make this minus 12 for one of the binomials and plus 4 for the other binomial. And a brief multiplication using your FOIL method would verify this. All right, how about this last case? Well, sometimes when it looks a little complicated like this, I have to go through and use my factoring, right? Factoring by just kind of fiddling with the digits and trial and error. That doesn't work for me. So I use a model. So let me try one here. This almost looks as if it could be like this. 6u squared minus 19u plus 10. Where did the u come from? Well, all I'm doing is I'm letting u, the variable, replace x and y in the expression. Right? And if you think about it, it kind of makes sense. All we're doing is just a one-for-one replacement so that we can see it a little bit easier. If I know how 6u squared minus 19u plus 10 factors, then I can factor this. Well, how would this one work? I'm going to use my grouping number method. I know that 6 times 10 is 60, and that would make a really good grouping number because I know there are factors of 60 whose sum is negative 19. In fact, negative 15 times negative 4 does indeed equal negative 6, does it indeed equal positive 60, and negative 15 when added to negative 4 gives me negative 19, which is my last term. So we can split this up and think of this as 6u squared minus 15 times u, splitting up the middle term, minus 4u plus 10 in our last term. We factor by grouping. In the first pair of terms, we can factor out 3u, leaving us with 2u minus 5. And from the last pair of terms, if we factored out negative 2, that would leave us with 2u minus 5. Remember, negative 2 times negative 5 gives us plus 10. So this is going to factor as 2u minus 5 times 3u minus 2. And that's good for us because in our polynomial now, we can think of this as being 2xy minus 5 times 3xy minus 2. That's our factorization. All right, good luck with the homework. See you in class.